I used to play basketball. I know how to play. Will you? Oh. Foul. Foul. Exactly. All right. Good afternoon, everybody. How we doing? Good. Fantastic. Now we have that protocol, the test behind us. We can get back to the real thing about BC calculus, which is learning and growing, picking up some more math skills. All right. For the past couple of days, week or so, we've been learning how to use integrals to find area. We've grown very dear and fond of our area. But now we're going to move into a third dimension. All right. So if area is how we find all of the space in a two-dimensional object, how do we find all the space in a three-dimensional object? Volume. Volume. Very good. Sharp class. All right. Volume. Volume is how we keep track of all the space in a three-dimensional object. Say, for instance, this object here. Does anybody know the name of this object? Anybody know the name to it?
Triangular prism?
It's supposed to be
It's like a
triangular.
veil on the side. It has
Veil on the
symmetrical
side.
Oh, it's like a ball.
Parabolic. A lot of names. That's good. This is actually called it's a cylinder, but it's called a right cylinder because the right side, of course, has the flat side. Can somebody raise your hand and tell me a formula that will help me find the area of this particular object?
Base. 9 times rho times height, I guess.
Length times width. I don't see a length anymore.
That's true.
Okay, well, let's move on to something a little bit more conventional, and then we'll come back to this one. What about this object? What's this object called? Cylinder. Can somebody raise their hand and tell me how to find the volume of this object? Brian. Pi squared E. Pi r squared h is the volume for this object. All right, let's see. What about this object?
9 times rho times height.
Length times width times height. It's going to work at some point it's going to work.
Yeah.
Length times width times height. All right. What's the commonality between these two?
It's the area of the base times the height.
The area of the base times the height. Very good. So then what would this one be here?
The area is
Are the bases
B1
the
and
same?
B2 separate?
They're separate but identical.
Okay, then area of B1 times H.
Area of B1 times H. All right. Times H. That's 5. All right, so he gave us a general formula that we can use to find the volume of any style of object. The area, volume is equal to area of the base times the height. All right? Now, here we go with our beloved area again. Why do we multiply by the height? Now, this is, of course, that third dimension that we were talking about, so this is what we added. But why multiply the area of our base times the height in order to get volume? Sean?
Because you found the base, so you have to find how many times the base goes into the entire figure. And so since you know the area of the base, you know how many times it's gone into that figure, you know the entire area.
Or how many times it's gone into that figure? Clarify that.
Like, since you know the height, it's what the height is in that figure. Like, if it's the height is 24, and 24 of the bases make up that figure.
24 of the bases make up that figure. That's correct. So 24 areas. So if I knew this area, and this area, and this area, and so on, all of those areas comprised give us our volume. So we just add up the areas. That sounds similar to a formula we've been using as of late, but let's not go there just yet. We'll get there in just a second. Adding up all the areas to make it. All right. Let's find the area or the volume of square root of x bounded on both sides by 0 and 1. All right, can I get, do we have a Picasso in here? Somebody that's a magnificent artist? I just want to see where your confidence level was. All right, do we have somebody that's a passing artist that can draw? There we go, Sherry. This here. Would you draw for us, what's your coordinate plane, and show us the square root of x, bounded on both sides by 0 and 1.
On the coordinate
Yeah,
plane.
you do, sir. X and Y axis. Use any color you like. Yeah, that's very bold.
Okay, and then.
Square root of x. Just, you know, square root of x, it's,
So,
there you go, bounded by 0 and 1
on the x-axis?
on the x-axis, 0 and 1. So it's a little dotted line that shows where the end of our, the 1 is.
Where this?
Yeah, there's, I mean, dotted line here shows where our boundary is. All right, so this is our object. Now, we've been finding the area of objects like this by taking small pieces and adding them all up, similar to what we were talking about in the volume. All right? Now, let's take this object, this shape, you know what we're talking about. This object here, and rotate it around the x-axis. What type of shape would that create?
Correct.
Probably more two-dimensional. Could you kind of draw and see what it looked like? So
Semicircle.
two-dimensional, rotate it around the x-axis.
Half of
How's it going?
Help me clean up the,
Yeah.
Oh.
Which one?
I see. Yeah, there we go. There we go. All right, very nice. See, you are Picasso. You are fantastic artist. I don't know why you're doubting yourself. All right. We're gonna need you again later on. All right, so this is our solid object, and our equation was that volume is equal to the area of the base times the height. We're going to take all of the areas and add them up. So what equation do we use to add up all the areas? When we were just finding this here, the area of this particular object, what equation do we use to add up all of the sections that we created?
The integral
The integral. So if we're doing the same technique for volume, what will be our equation to find the volume of this?
we find the integral of the given and then multiply it by the circumference.
The integral of the given multiplied, almost.
I think you take the integral and then you multiply it by the difference of the limits, like 1 minus 0.
Okay, what, the integral of what? What are we taking the integral of?
The square root of x, given equation.
A given equation. All right, so we're gonna take the integral of the square root of x. Now, what is the square root of x in terms of this? Does that give us, we're trying to find volume. Volume is equal to
Oh, take that.
the sum of our areas. So if area is equal to the sum of our lines, and volume is equal to the sum of our areas, how do we take the sum of our area here? What's the area for this?
take the double,
Hmm?
you take the double.
Well, no, not quite. Let's see, okay. What we're gonna do is take a slice. Single slice. It's like we took slices of our area, we're gonna take a slice of our object. What do we call this object?
Half a sphere.
Half a lemon.
Half a sphere. We're gonna take an object about half a sphere. What does this slice look like?
Line.
Like a tangent line.
Like a tangent line, half the slice of the sphere?
Oh, that's light.
So if you take a slice of an orange, it looks like a,
A cylinder.
it's just a slice though. A cylinder is three
A
dimensional.
two-
It's
a
just one
two-dimensional
slice. Yeah, just a slice.
slice? A circle.
It's a circle.